In complex collocated design activities, the success of the work often depends on collaborators' mutual awareness, the up-to-the-moment understanding of another person's interactions with the shared workspace, and the ability to jointly coordinate their actions. Mutual awareness and coordination depend in large part on the non-verbal communication in the physical space, such as deictic references, joint manipulation of the design artifacts, and implicit awareness of others' actions in space. Mobile augmented reality can support collaborative collocated design by enabling the creators to flexibly work with digital objects instead of the physical prototypes, while still being able to use the physical space for coordination and awareness. However, the effectiveness of mobile AR for coordinating collocated collaborative co-design activities is not yet clearly understood. We directly contrasted collaboration in mobile AR to that in the physical setting, to understand how mobile AR affects coordination and mutual awareness of the participants when designing 3D artifacts. Specifically, we focused on understanding and characterizing the differences between coordination behaviors that emerge in mobile AR environment as opposed to a fully physical environment. Generally, we found that these two conditions produced different coordination styles, but both were grounded in the physical environment, implying the importance of physicality for creative collocated tasks around 3D objects. In the following slides, we will describe our research in detail. We designed a controlled within-subject experiment in a lab with a large table at the center of the room. The pairs of participants were asked to co-design and co-build a structure on the table in two distinct conditions: physical condition and mobile AR condition, using similarly looking square blocks. In the physical condition, the participants collaborated placing real wooden blocks on top of the physical table. In the mobile AR condition, the participants collaborated placing virtual blocks on top of a real physical table, seeing the augmented environment through a tablet screen. The analysis of the participants' behaviors allowed us to identify three core aspects where differences in coordination patterns were significant, namely, the character of task allocation, movement around physical space, and deictic references. One of the most striking differences that we observed was the way the participants divided the work between themselves, allocating the building tasks between each other. Generally, during the physical condition, the participants allocated the tasks according to the same functional element of the structure, complementing each other's input. In contrast, the participants in mobile AR condition divided the tasks according to the different areas of physical space, working on different parts of the structure. For example, we observed how the participants built different walls of the structure separately from each other, based on where they were currently standing or sitting in the workspace. We noticed that the differences in participants' task allocation behaviors were due to the natural richness of communication available in the physical condition. For example, we saw how in the physical condition, the participants could easily adjust to each other's actions and predict each other's intentions by looking at each other's faces, hands placing the blocks, and directions of gaze. Contrastingly, in the mobile AR condition, the participants mostly looked at their own or others' tablets and tried to infer where their partner was working by looking where the new blocks were added into the structure. This form of coordination arguably allowed a less fine-grained understanding of each other's actions and intentions, resulting in the collaborators' overall preferences to focus on different areas to avoid interfering with each other's work. Another important use of the physical space for coordination was movement. Specifically, the participants often moved from place to place around the table, and these movements served as communication and coordination signals. Two aspects of movement were important: movement dynamics, meaning how much the users moved around the space, and formation choice, what positions they took relative to each other. In terms of movement dynamics, the increase in participants' movement was very noticeable in mobile AR condition. Large amount of movement in mobile AR was necessitated by an increased need of the participants to understand each other's perspective on the artifacts of work. Because they lacked a constant shared physical reference, the structure itself, the collaborators could not easily understand how the artifact looked from the perspective of their partner. Thus, they moved close to each other to see the artifact from a similar angle and direction of view. Moreover, in the physical condition, when deciding to work on the farther sides of the artifacts, the participants often reached the other side with their hands and stayed at the same place. In the mobile AR condition, the participants moved to entirely new positions instead, contributing to the overall larger amount of movements. Another component of participants' movement was end formation choice, namely how they were positioned relative to each other during the work. We distinguished between the near formation, when the participants were close to each other at the same side of the table, adjacent formation, when they are at the adjacent sides of the table, and the opposite formation, when situated opposite to each other. We saw that in mobile AR condition, the participants were closer to each other compared to the physical condition, standing at the same side of the table rather than on the adjacent or opposite sides. In the physical condition, the participants preferred to work on the opposite sides of the table more. As in the case of the overall movement increase, working close to each other in mobile AR was necessitated by the increased need of the participants to understand each other's perspectives on the artifact of work. To understand how their partners see the artifact, the participants moved close to each other to see the artifact from the same side. The next significant difference was in the amount of deictic referencing towards the artifact, such as hand, head, or torso gestures referencing the particular parts of the structure while building, or symbolically describing the parts of the structure using one's hands. While we observed a rich deictic behavior in the physical condition, in mobile AR condition, referencing had a mostly verbal character. Namely, while working in mobile AR, the participants often narrated their actions to keep their partners in the loop, or verbally called for the participants' attention. Also, they referred to different parts of the artifact by verbally describing its location, form, or functions. In terms of overall user experience between the two experimental conditions, we noticed that the only significant difference in the participants' ratings was observed in their perceptions of the quality of collaboration during the task. In fact, the participants rated the quality of collaboration as being higher in mobile AR condition compared to the physical condition. The participants mostly felt that the two conditions were very similar to each other. They said that mobile AR was like the physical condition, but with additional extended capabilities. Our findings suggest that physicality serves as an anchor for coordination, highlighting the importance of the shared physical dimension for facilitating collocated collaboration. In the physical condition, the existence of the shared physical artifact allowed the participants to use it as an anchor for their coordination needs, leading to the object-based coordination. In the mobile AR condition, in the absence of a shared physical artifact to coordinate around, the participants used the workspace itself as a locus for their coordination, leading to the space-based coordination behaviors. Please read our paper for more details and discussion.